Hello and welcome back to Algebra 2 with Mr. Austin, Mr. Lambright. Mr. Lambright back again. Today we're going to talk about solving linear inequalities. As always, your notes. If you're either going to be getting a copy of those off of Canvas, getting a copy from me in class if you're in class today, or you might be writing these in a notebook, and that's fine too. Let's get started. So, inequalities, we know from back in the day, we've got these four different symbols. They are less than, greater than, less than or equal to, greater than or equal to. And they basically mean that the answer covers a range instead of just having one answer. An answer is a solution to an inequality if, when you replace the variable, the inequality it's true. So if I said 0 is greater than -3, that would be true. 0 is greater than -3. But if I said 0 is less than -3, no, not true. It is not a solution. And then we graph the inequalities by putting them on a number line, and you're actually going to see that here in this first example. So this is asking us to graph x is less than 2. And in order to make sure that I have room, I know in the past you may have started at 0. I'm always going to put the number that I want as part of my solution right there in the middle. And so I know the numbers above 2 are 3 and 4 and 5, and below that are 1 and 0 and -1. So we have some choices to make. We know we're going to have a circle on 2 because that's the number that x is related to based on the inequality. The question is this going to be a filled circle or an empty circle? If we had an equal to, it would be filled, but we don't, so this circle is going to stay empty. And then because x is on the left side of the inequality by itself, we can use the inequality as a direction arrow to tell us, oh, all of the numbers to the left, see the arrow matches the inequality, that is the solution set. So every number covered on the number line to the left is a part of the solution to x is less than 2. Time to make those decisions for a new inequality. We know we're going to have a circle on -1 again, and we have to ask ourselves, is it filled or is it empty? And this time we have the equal sign. So that means this inequality is filled in. Then we have to ask ourselves, does the arrow go left or right? It goes right, so we draw our arrow to the right. Everything, including -1 and to the right of it, is part of the solution and would make a true statement if you plugged it in for x. We also have these things called compound inequalities. Basically, a compound inequality is a combination of two inequalities, the same way that a compound word is a combination of two words. We have the inequality x is less than 2, and we have the inequality x is greater than -1. If I flip that around so x was on the right, that's what it would say. X is greater than -1. So what I'm going to do is I'm actually going to be able to graph the area where both of these things are true. So first, I'm going to put a circle on 2. And it's going to stay empty because there's not an equal sign. And we know this one's going to go to the left, right? But we're not going to do that yet. Then I'm going to put a circle on -1. And everything greater than -1 is to the right. So the area that is covered by both is this area. So 0, 1, numbers in between like 1/2, they all satisfy the solution set. The important thing is this is an and inequality. It means that it's between these two circles. So when the x is between the signs like this, the solution set is between two circles. And the circles are on the numbers that x is between. This problem is going to be exactly the same. I've got two inequalities. So again, x is less than or equal to -2. And x is greater than -5. So I'm going to put a circle on -5 for that inequality. I'm going to put a circle on -2 for the green inequality. I have to ask myself, are either of these circles filled in? And with this equal sign right here, I know that the 2 is filled in, or the -2 is filled in. And the -5 is not filled in because it doesn't have an equal sign. And once again, because x is between these two numbers, we are going to draw our line between them. Solving an inequality is very much like solving an equation, but there are two things I want to keep in mind. Thing one, I want my variable on the left. That didn't matter in the equation, but it does matter here. And then I also know that if I divide by a negative, the sign flips. We're going to see both of those things in this very first problem. Now, when I was solving equations, something that was really important to me was I thought it would be easier if we would move the variable, because I've got a 7x on the right, I've got a 5x on the left. In the past, I would move it so that there weren't negatives to deal with. But in this case, I really need that x on the left. So I am going to subtract 7x, and that means both of the x's are going to be on the left now, combined down into -2x. The +2 comes down, the greater than comes down, the -4 comes down. Now this is a two-step equation. So we are going to subtract 2, cancels here. And finally, to get x by itself, I have to divide by -2. This is a problem because my second note that I had up there was that the sign has to flip if I divide by a negative. So yeah, the -2's are gone on the left. I've got x. My sign is now less than, and -6 divided by -2 is +3. And that's my answer. Same exact process on the second one. We're going to subtract x, which is really 1x, from -1x. We've got 3. -1 minus 1 is -2x. And then everything else comes down. We're going to subtract 3. Remember, we don't subtract what's on the right. We subtract that constant. So -2x comes down. That's -12. And we have another problem where we're dividing by a negative. We'll divide by -2. X is now less than, the sign flipped. X is less than 6. The math is the same except for the signs flipping and making sure the variable is definitely on the left. But please, if that went too fast, pause here because I'm going to go to the next slide. Now we have a compound inequality to solve. You see, x is between these two different signs, but it's in between the signs with a few other things that we need to get rid of. So I basically have two inequalities here. I've got -4 is less than 6x minus 10, and I've got 6x minus 10 is less than or equal to 14. But instead of solving two different inequalities, I can do this all at once, and that's what we're going to do. Everything I do to the middle, I have to do to the left and to the right. So if I'm going to add 10 over like I normally would in an equation like this, I have to add 10 here and add 10 here. So -4 plus 10 is 6, less than 6x, less than or equal to 24. Then I still need to get x by itself, so I divide by 6. Divide by 6, divide by 6. 6 divided by 6 is 1, less than x, less than or equal to 24 divided by 6 is 4. So we've also been asked to graph this, and we know that we have to have 1 on here, 2, 3, we have to have 4 on here. I'll always put at least one more out to the side. And I know that over here at 1, I'm going to have an open circle. And at 4, I'm going to have a closed circle because of the equal sign under the sign. And because it's an and inequality, it's between two numbers. We are graphing between. And that's it for solving a compound inequality. Whatever you do to the inside, you have to do to both the left and to the right. So sometimes when we solve two inequalities at the same time, they don't have an answer that goes between two circles, and that is called an OR inequality. That means x is less than something or it's greater than something else. And we're going to see exactly what that looks like right now. So we're going to solve these two inequalities. I'm going to subtract 5 from both sides here. 3x less than or equal to 11. Oh, I'm sorry. That was 11 minus 5, which is 6. And we're going to divide by 3. X is less than or equal to 2. Then on this side, we're going to add 7. 5x is greater than or equal to 30. Divide by 5. X is greater than or equal to 6. So let's check this out. We've got 2, 3, 4, 5, 6, and then I'm going to go out one more for good measure. On 2, I've got a closed circle because it is equal to, and it's less than, so it goes to the left. On 6, I've got a closed circle because it's equal to, and it's greater than, so it goes to the right. When you have an OR inequality, you've got one going left, and you've got one going to the right. That's the last problem for today's notes. If you've got questions, make sure to message your math teacher on Canvas and check out what we've got on Canvas for your next assignment. Thanks, and I look forward to helping anybody who needs it. Bye.